This video will focus on being able to distinguish between saturation levels of solutions, and then also a little bit about how we supersaturate a solution. So when it comes to the question, how much can I dissolve? Essentially, there's three ways we talk about it. We can talk about having a saturated solution, and a saturated solution means I dissolve the maximum amount I can. In terms of the make and break bonds, I'm unable to do more than what I've done. I get to essentially what's called an equilibrium. And that equilibrium point is that bonds are still being broken and reformed, but essentially the bond reformation is happening back in to the old bond as well as to the new water bond in equal directions. So I'm not making any new ones anymore because I keep remaking kind of my old ones too. So based on the ability to dissociate and hydrate, if I'm unable to do that anymore, I'm saturated. And how you'll know you're saturated is if you have a solution and you put in some solute and it just falls to the bottom and nothing happens to it, I'm saturated. I can't dissolve anymore. Unsaturated simply means then I'm less than the maximum. Not super interesting. If I put a salt or a solute crystal in and it's unsaturated, it'll dissolve. Supersaturated is a super special case, and it's not super important in your life other than it does happen in real life. We do have reusable hot packs that use supersaturation as a concept. And the deal with supersaturation is you can heat up a liquid and dissolve solute in it to the saturation point at that higher temp. Right, the solubility of a substance at a hotter temp is higher, so I can dissolve more solute into it. And then for certain substances, after I dissolve it at a hot temp, if I let the solution cool down, it doesn't do what most substances do. Okay, let's talk about what most solutions do. If I saturate my solution at a hot temp and then I let it cool down, essentially as it cools down, what you'll see happen is you'll see crystals come out, all those crystals that are beyond the saturation point for the lower temp. So if I could dissolve like 20 grams in 90 degrees, but only like 15 grams at 70, once it gets down to 70, 5 grams of solute will have just recrystallized out. They will have reappeared in my solution, simply because the solution can't be beyond its saturation point. Okay, so it'll keep recrystallizing to become what the solubility is given the temperature. A supersaturated solution, on the other hand, if I could dissolve 20 in at 90 and only 15 in at 70, when I get to 70, all 20 are still dissolved. Okay, so supersaturated solution does this really cool thing where as you cool it down, it doesn't recrystallize. It stays saturated beyond the saturation point. Okay, and the only way to do this is you have to heat it up and let it cool down super slowly. Okay, and then what will happen is you'll have maybe like room temp solution that essentially has all these crystals dissolved into it that you can't even see and that are beyond the saturation point. This holds in a lot of energy because essentially you have all these bonds that didn't get to break and remake that are just sitting there kind of waiting to have something happen. And what's really cool about it is for a saturated solution, you put a crystal of solute in and it just falls to the bottom. Unsaturated, you put a crystal of solute in and it dissolves. Supersaturated, you put a crystal of solute in and it's like you wake up the solution. And not only does it not dissolve, but all the crystals that were in there beyond the saturation point just fall out. And all of a sudden you have all these crystals that just a second ago were all dissolved. And because we're making and breaking all these new bonds, you also get a whole heck of a lot of heat usually, which is why this is used for a hot pack. Just to make sure if you haven't gotten these notes before, here they are. I keep using the word solubility. If you don't have the definition, there it is. That's it for this video. Have a nice night.